Now that we've looked at a couple of rational function graphs, let's try to come up with a rule for finding the vertical asymptotes for rational functions. We saw that our graph of 1 over x had a vertical asymptote on the y-axis. Now the equation of the y-axis is x equals 0, which is the same as setting the denominator of that function equal to 0. Our other example had a vertical asymptote at x equals 1, and notice that we get x equals 1 if we set the denominator of that function equal to 0. So if f of x equals p of x over q of x is a rational function where p and q are polynomials and the fraction is reduced, then we can set q of x equal to 0, the denominator equal to 0, and solve for x to find the vertical asymptotes of the graph of f. And that's what we're going to do in several examples now as we move forward. We'll explore how there are 4 possible shapes of the graph near a vertical asymptote. So this one, this possibility, this possibility. It's like 2 hands up, 2 hands down, 1 up, 1 down, 1 up, 1 down in the reverse order. And so you may need to evaluate the function at x values close to the asymptote in order to choose the correct shape. And again, we'll look at that more closely in the examples. I want to give you just one fairly simple example here, the graph of f of x equals 1 over x to the 4th. When x is positive, the shape of this graph is kind of similar to the graph of y equals 1 over x. The points are in different places, but the shape is similar. When x is negative, however, though, notice that 1 over x to the 4th is positive, so it's going to be different from y equals 1 over x. Also, f of x equals 1 over x to the 4th is symmetric about the y-axis. If you replace x with minus x, we get an equivalent function. This is also called an even function. So the graph is on the next page. Let's take a look. And here's the graphs right up here. And so notice that I just wanted to pull out this example as an example of a function where the 2 branches of the graph rise up along a vertical asymptote from each side. That's to contrast a little bit with f of x equals 1 over x, where one branch goes down, the other goes up along the vertical asymptote. Now, we haven't seen an example yet, but we will, and we're about to. A rational function may have more than one vertical asymptote. It could have 2, 3, 4, 5, 6, any number. So determine the vertical asymptotes of this rational function, x squared plus x minus 6 over 2x squared minus 5x minus 3. So we're not going to graph this one. We're just going to try to find the vertical asymptotes. Notice that f of x is reduced, because we do need reduced form when we're looking for vertical asymptotes. So what I'm going to do is just set the denominator equal to 0. And this is a factorable trinomial. So I was able to factor into 2x plus 1 times x minus 3. And so I can set each factor equal to 0 separately and solve, and I get x equals negative a half or x equals 3. So this rational function has 2 vertical asymptotes. So I set the denominator equal to 0 and solved. The vertical asymptote location has nothing to do with the numerator. Also, one last thought here. A rational function might have no vertical asymptotes at all, and we should be just prepared for that possibility. Here's a function x over x squared plus 1. If we set the denominator equal to 0, here we have x squared plus 1 equals 0, which when we go to solve that little quadratic equation, we're trying to take a square root of a negative. There are no real solutions to that equation. So you can express the solutions with I, but remember those imaginary numbers don't appear on graphs. So there's no real solution to this equation. So the function has no vertical asymptotes. And I even snuck in a little sketch of what the graph of that rational function looks like. Actually, it does have a horizontal asymptote, but it has no vertical asymptote. So that's that, and we're going to talk a little bit about shortcuts for finding horizontal asymptotes in the next segment.